Right, good morning. Today we are going to solve quadratic looking functions. The word is looking. It's not quadratic equations. We're going to solve quadratic looking. So why don't we go over and see what we did last time. We solved quadratic equations. What is quadratic means? Basically it's square equations. Square. You need to have stuff with a square around it, such as this one. And one of the basic methods is you factor it out, set each piece into 0, and be done with it. But most of the time it's not gonna work if the numbers are ugly, such as if I make this 66. Nope, it's not gonna work because it's not gonna separate the way we want. So for those kind of situations we have the most powerful method. It's called quadratic formula. Basically all you need to look at is decide ABCs, put them back in, watch for the right order of operations, do them correctly, and then compute all the way and solve it. That was pretty easy. So you know now you're master of solving quadratic equations, right? You can solve any quadratic equation. All you need to do is supply these numbers, correct? Almost.
In theory, yeah.
Oh, in theory. You just need to practice more. Now, we are gonna take it into next level now. Those skills, not perfect, but you have some skills now. We're gonna put it into work and solve more sophisticated equations. They are quadratic looking. I call this quadratic looking form. Quadratic looking equations. Why? Why they are looking, not quadratic? Because when you essentially square this thing, what happens if you square 2x squared? What kind of power do you get? 2x squared, when you square it, it becomes 4x to the fourth. These powers join in and make fourth power. So if you have a fourth power in an equation, you can't call it quadratic anymore. It's not quadratic, but it's quadratic looking by looks. Why? Why is it quadratic looking? Look at this. You have a square. You have the first power, just like in the previous question, x squared, x, and 65, or 66, whatever it was. So when you just switch the stuff under the square, call it a variable, anything you wish, u, z, t, any label you want, but in math we usually call the substitution variable u. If you substitute, replace 2x squared minus 5 by u, look what it turned into. At first it wasn't quadratic, it wasn't, but when I make a simple replacement, it turned into quadratic now. Look, square, single, number. That's all you need, 3 terms. Square term, single power term, and a number. Okay? So that's what we are going to do today. We are going to substitute things with u and turn them into quadratic and apply what you learned yesterday, quadratic formula or factoring method, whichever you like, and solve these things. Here is our first question. Number 1, you have stuff squared. Look, I just want you to ignore what you have right here, or it's called color this off. Cover this up. Cover this up. What do you have? I have something squared plus 10 times that thing and a number. It's just whatever you have here underneath makes it confusing. But no, don't be confused. All you need to do is take a different color pen and call them u. So I will make this thing u and this thing u. Oh, by the way, these two things, to be able to call them the same letter, they must match. Is it n squared minus 2n in both sides? Yes. If this was plus 2n, you couldn't do this method. Quit it. You can't solve this equation. Alright? Go solve another one if this is a plus, because it's not, they are not the same. You can't call them the same thing. This is t, for example. It's not u anymore. Okay, now they are both U, and before you forget, whatever substitution you made, put it, record it. This is the recording page. On one corner, record it so that you don't lose it, because we will always go back to this side and finish off the question here. So we will always, you need to turn always back to original variable, because U is something you made up. You need to take it back, because you made it up. You need to take it back and get the final result in the original variable. So record what you called U to be here. You assigned U to be what? N squared minus 2n. Record it here. We will come back to this. Now write the new equation with u's now. U squared plus 10 times U equals 11. Now, isn't this question just looks very similar to what you've been doing yesterday? Look, isn't it just like this one, or this one, or even this one? U squared, some many u's and a number. Except in all these questions, and to apply quadratic formula, what do we need to have on the other side? 0. So this is not quite standard form yet. I don't like 11 on this side, so what shall we do? Flip it to the other side by subtracting 11 from both sides. Now it's gone, and turn it into 0. So we have the perfect standard form quadratic equation, U squared plus 10U minus 11. Okay? Now how do you solve this? How do you solve it?
Plug it into the formula.
Yep, I know you guys want to reach at the most powerful weapon first, but why don't you use the easy one first? Because that quadratic formula takes a while, right? What is the easy way? If it works, it's fast. Factor it, right? Can you break this into two pieces with one U on each one? All you need to find out, try to find out, is how do you break 11 into two numbers? Multiply two numbers that will make 11, and multiply those two add those two numbers, add. It needs to make positive 10. When you multiply, it's gonna make minus 11. When you add, they're gonna make 10. What two numbers do that? 1 and 11.
Negative 1 and 11.
If I choose both positive, you won't get negative 11, right? So we flip 1. Which one did you flip?
Negative 1.
Negative 1. We flip the positive one to negative, so this way minus 1 times 11 is minus 11. And minus 1 plus 11 is positive 10. Both checks. That means this question can be solved by factoring skills. Chapter 6 formulas. You don't need the quadratic formula, but if you wish, you can do quadratic formula, and it's gonna take a couple more minutes. But I just like, if I can factor it, it just goes very fast. Once you factor, all you need to do is set each part into 0 and be done with it. I just need to add 1 to both sides here, subtract 11 from both sides, and all done, right? 1 and minus 11 are the answers. I'm going to do this. We are going to go and plug them into the solution set, and we're done with it, right? Am I right? I don't think so. This was 11.2, right? No, 3. I have so many homework piled up. Yes, I found two solutions. Wait a second, it says incorrect. I couldn't even try my solutions. I found two and it says, no, sir, it's incorrect. Where did I mess up? What are these values I sought for? What variable these numbers for?
N squared minus 2.
Yeah, this reads, when you read, it says u is 1. I solved u's and these are for u's. But did they ask me what u's are in this question? They're asking what n's are. So you can't give them u's because they won't even know what u is. U is a variable you made up. So you need to go back, enter those values you found for, what was that? You found u as 1 and negative 11. I promised you're going to use this site, right? You need to first try u equal 1 and solve for n, and then you will try u equal minus 11 and solve for n. Wow, so this question has maybe 2-3 parts. Each individual part can be a question on its own. Okay, so we will first try u equal 1 in this equation. So u equal 1 is going to turn this thing into 1. And you're going to solve now this equation. What kind of equation is this? Is this a linear equation? Is this a cube equation? This is another quadratic equation. So this is another problem you need to solve. Look, you have a brand new quadratic equation just like this. You need to work this out and solve it. But to be able to solve a quadratic equation, I need to have this side 0. So I will first subtract 0 from this side and subtract 1 from each side and get this side 0. You have all three present on the other side. Now, which method you want to try? You can do quadratic formula. You can do factoring, just like here. So try. So do you want to try factoring first? Can you break minus 1? By the way, first terms are n. Can you break minus 1 into two numbers, here and there? When you add them, it's going to make minus 2. Are there such numbers? I'm thinking positive 1, negative 1, they will make 0. I'm thinking 1 and 1, but positive 1 and positive 1 won't make minus 1 when you multiply, right? I'm thinking minus 1 and minus 1. Minus 1 times minus 1 will make positive 1. It's not going to work. So can I take minus 1 and 1? Yeah, they will add to minus 2. However, when you multiply, it's not going to make minus 1. Because minus 1 times minus 1, negative 1 makes positive 1, right? So I quit. Factoring is not working this time. I'm out of luck. So what shall we do? We will do, what is this called? Yeah. Assign ABC's substitute, solve, find out. So B is minus 2, right? This is B, this is C, here is A. Oh, it's absent, that means it's 1. Again, the variable you're solving for is n, not x anymore, so I call this side n. Minus 2, negative of minus 2 is positive 2. Minus 2 squared is 4. Whole thing divided by 2a, which is 2 times 1, 2. Alright, where do we start? We always start from the tail. Inside the square root from the end. This one should be computed. What is minus 4 times 1 times minus 1? Positive 4. 4 plus 4 is, now this all three gone. So you have 4 plus 4. Addition of 4 and 4 makes 8. Alright, can I save some people from this jail? 8 is not a whole square root. When you put it in a calculator, it won't give you a whole number. It's a never-ending number. But you can at least save some from prison. 8 has 2 factors, 4 and 2. You can take 4 out. So 8 is 4, 2. I can bring 4 out as 2. And 2, one of the 2's is still stuck. So this is what you have. The other 2 remains, but 4 comes out as 2's, all free. And one more thing. 2 divided by 2 is 1. 2 divided by 2 is 1 when you cancel it. So the result is 1 plus minus 1 root 2. But 1 root 2 is the same as just root 2. You got 2 solutions here. 1 plus root 2 is the first one. 1 minus root 2 is the second one. There you got 2 right here. Okay? So before we forget, let's put it in a box. 2 solutions already here for n. There may be another 2 for trying minus 11. Minus 11 is coming up next. So we will try now. U equals minus 11. This guy, I tried this one. This is coming up next. In the equation, u equals what? N squared minus 2n. So all you need to do is take this minus 11 and substitute in u. But I need to have minus 11 on the right side, so add 11 to both sides. And you get still 0 on the left. Please, I want to have something factorable now. Can you factor this thing, guys? 11 minus 2. Pick 2 numbers, multiplying into 11, adding into minus 2. Can you come up with a pair of numbers like that? Multiplying into 11, adding into minus 2. If yes, the question lasts only 15 seconds. If no, we gotta do another round of quadratic formula. Alright, I don't hear anything. That means we need to go with quadratic then. This time your ABCs are different. A is 1, B is 2, C is 11. So let's substitute all these. 2 plus minus 4 minus 4, 1, 11. Wow, what a messy question, right? How many quadratic formulas we've done? Twice, and 1 factoring method. 3 tricks. Twice times 2 times 1 is 2, by the way. Alright, and something happening for the first time. We've been using quadratic formula since yesterday. We've done it almost twice today. And for the first time you're encountering this. What are we encountering?
Negative in the square root.
Yeah. This thing is minus 4 times 1 times positive 11 is minus 44. 4 take away minus 44 is minus 40. We've done so many quadratic formulas. For the first time you have a jail with a disease. What is the disease? Minus. So how do you cure that disease?
Well,
Bring it as out as I. Yep. Take this guy out and call it I. That 40 is a big number, can be factorable. I believe you can pull some factors out. I want to do the easy way. I see 4 times 10 there, and I know 4 comes out as 2. Instead of all the way factoring, I know this factors as 2225, 2225, but you have double 2 coming out, single 2 remaining, 5 remaining, which is 10, 2 and 5 remaining, so only 4 is coming out. Agree? And same deal here. Twos again canceling. Look, these 2 and these 2 again canceling. 2 divides 2, 2 also divides that 2. This time the answer is 1 plus minus I root 10. But I like putting I to the end. So when I'm, what's that?
Put 1i plus or minus.
Oh,
Just done I plus or minus 10. Square root of 10.
hold on. What do you, let me type in what you're saying. So you're saying this is equal to I?
I'm saying it can't, I'm asking you, could it not be I plus or minus square root?
No, this I is multiplying this. How did you bring it in front?
I'm just asking it if it can or it can't.
No, it can't.
Okay.
No. And what happened to this 1? I mean, it looks like you're flipping it, but no. I mean, this 1, I and root 10 is not separable. You can't move I all the way in front that way, okay? So, no. Just move it to the end. Root 10i, you can do. You can flip these 2, but not that nice. So this is the second pair of solutions. Do you see 2 solutions here as well? 2 here, 2 here. In total, how many you have? 4. Express numbers in simplified form using integers. It doesn't say complex, but I'm a little bit suspicious, but let's see. No? Usually in the questions it says put it in a plus bi form. I was a little bit cautious, it didn't say here, but it worked. Okay, 4. And those were, oh, they want it all separate.
Negative 11.
I don't see a plus bi. Yeah, we need to do 1 by 1, separate 1 by 1. 1 plus root 2, 1 plus root 2. The first one, 1 plus root 2. Second one, 1 minus root 2. 1 minus root 2. The third one is 1 plus root 10i. 1 plus root 10i. And the last one is 1 minus root 10. You see I brought I all the way to the end after square root. Wow, what a question. So if you get this question right, you mastered your quadratic formula skills, factoring skills, everything kinda, okay? So it's a really big chunk of question. Any questions? Did you get the idea though? I mean,
We do a full one on our own.
hmm?
We do a full one on our own.
Full what?
Can we do a full problem on our own?
Yeah. Go try this one.
Not that one.
Yeah. Do you want to do it right now? Do you want to try another one?
Well, now that I know that there's more stuff to come now.
Okay. First, try this at home, okay? On your own, really you're on your own. Maybe next time, remind me, we just redo one of these questions, okay? Because we will pretty much repeat same basic things stuff on this question as well, but this is a different one. You see, there is no more squares around, that's parentheses. So this is a little bit different strategy. But we know what to do. You guys need to do this. You need to change this into square of something plus whatever thing you got here is with single power, maybe some number in front, okay, and a constant number. Oh, this -6 is not gonna change, and 0. So couple things won't change. This will stay, equation symbol will stay, but you need to flip these into something looking square looking plus single power looking. And when you do that, you cannot get these two items different. They must be same. That's the trick. So this is the basic scope of the work. You're gonna use your smarts, make this square. This is 1, power 1. It's not that high actually. It's
Square root of 1 to n root of 3.
Yeah, you actually got it. So you're saying, you said nth root of y, what root of y?
3.
Third root of y squared. He used the fact that if you have m over n, it turns into m out to n in, n goes to the index and y goes to here. So in this question, 2 is coming out, 3 is going in. Or if you don't like this, there is another way. There is another way. If you don't like cube roots, this is what I'm gonna do. Let's use basic fraction knowledge. Can I root, there is a 2/3 here, right? I'm taking it right here. Can I write 2/3 as 1 over 3 times 2? Can I do that? 2/3 means twice 1/3. You can separate the numerator out and put 1 in the top, right? Because 2 times 1 is 2 again. And actually you have 1 here, 3 times 1 is 3. But we don't have to show 1 underneath this. Okay. So can I write y to the 2/3 as 1 over 3 times 2? And this is already 1 over 3. Look, do you see the match? 1 over 3, 1 over 3, 2, extra 2. And then -6 and 0. Here's what I'm gonna do. Ta-da! What do you see? You have, I just separated a multiplication of powers with a parenthesis. This is square of y to the 1/3, and this is just 1 to the first power of y to the 1/3. And look at this. This is a match. Does it make sense? Does it make sense? Can you follow? Okay. Let's do the recording now. It's time to substitute. What do we substitute? You call something u and record it here. What do you need to call u this so that this turn into a quadratic equation? What is u? Yeah, basically everything under this parentheses is your u, y to the 1/3. So this thing is your u. This thing, when you call that u, of course this is also u, but this u has a square, this u has a single power, You add 1, you add them and subtract 6 and set it into 0. So I call this parentheses y raised to the power 1/3, call it u. Question is, how do I solve this brand new problem? U squared plus u minus 6. What is the easy way? Yes, factor. Factor first. If it doesn't work, use the canon, which is quadratic formula. Alright, how does this factor if it factors? I don't know yet.
U plus 3 and u minus 2.
Plus 3 minus 2. 6 breaks into 3 and 2. When you add them, they make positive 1u. Perfect. So we can solve them then. Oh, I need to first set them into 0. And we get u is minus 3 and u is 2. Put them in a box. These are intermediate solutions. You almost got the solutions, except they don't ask what u are. You found 2 u's. They want what y's are. They are expecting y's. So you need to recall what u was and put it, take it from the recording page to here and substitute them here and there. So what is u now? When you substitute back, u is y to the 1/3. U is again y to the 1/3. So I'm trying these values. I substituted back. Now we guys need to get y. How can I get y? It's protected by a power 1/3. I need to cancel that power 1/3. How can I remove a power around a variable? I need to get y. Yeah, anyone? Square rooting is not gonna work. If you put square root, they won't cancel. You need to put something around. You're close. You need to put something around it, but that thing must cancel 1/3. You use reciprocal if you have negative, like negative powers. You use reciprocal and make this. Is this what you mean? You have a negative power, that's what you do. This is a positive power, so we'll not reciprocate them. Technically, let's remember what Chris said earlier. 1/3 was cube root, right? Think this as cube root. How do you guys kill a cube root? Okay, let me ask you this. How do you guys kill a square root like this? There's a square root. How do you kill a square root?
Times it by.
Or you square it, right? The right weapon to cancel a square root is squaring it. What is the right weapon to cancel a cube root? Cube. Yep. Cube both sides. Cube it. Or in other words, the right tool here was to raise both sides to power of 3. So 3 times 1/3 times them. When you times 3 and 1/3, they become 1. They become just y on the left side. Or here. Doesn't matter. They cancel and become y only. But what is cube of -3? Isn't this -3 times -3 times -3? What is triple -3? Minus
Minus 1/3.
minus 27. Yep. So you found the first solution. Congratulations. Get the other one next. Yep, we're gonna cube again. No new tools, still the old stuff. Cube again. Y, these cancel when you multiply. Y becomes 8. Minus 27 and 8 are the results. This wasn't too bad, huh? Two solutions. Do you want to try one on your own? No? Okay, let's proceed then if you don't want to. Alright, here comes any question. New question, new trick. All you need to do is find a way to make a square here. How would you square y? Oh, you want to square both sides? It will bring a square on this guy, but it will mess up this one because when you square this, you will still have square roots when you foil this, because you need to foil it. Okay, so it looks, I mean, if you're this is wrong squaring it. Squaring this means doesn't square first and second. You need to foil it, and when you foil this thing, it's square of the first and square of the last terms, yeah, but you also get outside and inside terms. 7y root 7y minus 7y root 7y. No, these are y's. Plus this, and this minus 14y root y. You still have problem here. This is 49y. 7 squared and root y is this. And this is still bad thing. You need to get rid of this, because this is not quadratic. If this was gone, it would be quadratic. Square and single power are quadratic, but with this is bad. It's not, squaring is not gonna work. Back up, back up, back up. We need to do substitution. It says substitution. We need to look at this. So looks are deceiving. This is not actually y. You need to look at it as a square of something. What is y square of? Can you turn this into square of something? And this is minus 7 times that thing. And oh, by the way, I want to add both sides 10 and bring this minus 10 to the left side, please, because I want all three together 0 right side on the right side. Again, you need to look at y to the first power as a square. How do you do that? Anyone knows? Okay, y will still stay. I need to assign a new power to y. When I multiply these two, it's gonna make 1. What is that new power, guys? What number multiplies with 2 and becomes 1? A half. 1/2. There you go, you found it. Y to the 1/2 squared becomes 1. There you go, you've raised this into a square now. And this is gonna be a candidate for your u. This is what I'm gonna call u. But wait a second, I need to have these two matching. But what I have here is square root y. They are not matching. This is y to the 1/2. This is square root y. So they are not matching, so I can't use substitution method here. Yeah, they are not matching. To be able to use substitution method, I must have same stuff on this too. I don't have same stuff. What's going on?
Unsolvable.
Hmm?
Unsolvable.
No. They're not, they're looking different, but they're actually not different. You don't see that? What is this again? You can put M outside, or alternatively you can carry M inside. Now I want you to look at this side. Isn't this square root raised to the first power? Right? N is 2, M is 1. When you change this into power, what does this flip into? I'm sorry. Let's make these with y's so that we can have a fit. Y to the M, y to the first, N is 2. What does this flip into when you flip? It becomes 1 over 2. 1 over 2. 1, 2. Mn. Mn. Right? So, isn't this thing now the same as this? Square root first power of y is y to the 1/2 as well. It's a match. So they wrote these questions. They didn't just randomly come up with these things. They just fixed these questions that they can be matched. This is when you call this u, this is the same thing, so you call that u as well. So the problem you have here is u squared minus 7u plus 10. Okay? Oh, I forgot to record. What did I call u to be? U is y to the 1/2, power 1/2. Y to the power 1/2. Alright, what is next? We always, before trying quadratic formula, I try to factor this. Can I factor it? What are the two factors? Set them into 0. Solve. And this is not the result yet. You need to recall what each u was from the recording page. Each u is y to the power 1/2. Now I need to get y alone. How do I get y alone? I need to erase that 1 over 2. Can I wipe off 1 over 2, cancel 1 over 2?
Square root.
Not square root, square. Yeah, we will square both sides and that 1 over 2 will go because 2 times 1 over 2 is 1. So you have 4 and 25. 2 squared is 4. 5 squared is 25. What happened to 1 over 2 again? 1 over 2 times 2 turned into 1. So it's just y. Okay. 4 and 25. Two solutions. Technically, you need to test these before submitting. plug in 4 here. So you get minus 10, yeah. 25, yes as well. 25 minus 35 minus 10, yes. So you should be checking them, but it's safe for 25 is the answer. Are you with me? Any questions? Any part you missed? There's one question left only. Let's take a look at this one. This is quite different. There is no more partial powers, 2/3, 1/2 like that. There are big powers now. Look, in this question, big powers, 4, 2, 8. How can I make this? Again, our goal is the same. I need to make the first one into square, the second one into, to take the number out, 2 with a single power. 8 and 0 will stay the same. What do I need to choose inside? So when I square, it's gonna become 4. What do I need to choose? Something here. When I raise it to power first power, it's gonna make z squared. Come on, this is a no-brainer.
Z squared.
Yeah, it's just z squared here and there. Look, once you square z squared, it becomes 4th power because 2 times 2 is 4, right? You multiply double powers. And 2 times 1 is 2. So RU is, what is the U we called here? Recorded. This is the U. And it's matching in both spots. It is Z squared. So U squared plus 2U minus 8 is what you're supposed to solve. Questions start off easy, but let's see if we can factor it. If we can't, we need to go hard way and do quadratic formula. But can you factor this? Can I factor it?
Yeah.
What are the numbers?
4 and -2.
Positive 4 and negative 2. When you multiply 4 and negative 2, we get minus 8. Add them, you get positive 2. Perfect. Oh, this is a dangerous one. I set each into 0. We got 2 solutions. Preliminary solutions. They are not real solutions. We need to now recall what u was. U is z squared. And put it back in 2 spots. So z squared is negative 4 and z squared is 2. Okay? Now, this time we're doing something backwards. This time you have a square to cancel. How do you cancel a square around a variable? We take square root of both sides. And I'm making a mistake. Let's see if anyone's gonna catch it. Square and square root cancels. We have square root minus 4. Oh, minus needs to be cured. This is a disease in as jail as I. So I'm bringing I out, 4 in. But square root of 4 is 2. So the result is 2i. I'm just flipping this. 4 is 2. I is here. Okay? On this part though, it's just these 2 cancel. And I can't take 2 out. It's z equals 2. So I have 1, 2 solutions. I tried this on here. And it says Incorrect. Why? Where did I messed up? Right. When you take square root of both sides in an equation solving, square rooting requires plus and minus sign in the number side, not the variable side, in the number side. Where is the number side? Here, here. Plus and minus. So you have plus minus 2i, two solutions, plus minus root 2, another 2, in total 4 solutions here. And we need to type all of them. So root 2, I will start with the real ones. Root 2, negative root 2, two I, negative 2i, positive 2i, negative 2i, and all done. Okay? Any questions?